This is my final project for statistics created by me, Ali Rajguru. My topic is average rainfall going up in Houston as global temperatures rise? The reason I wanted to do this topic is because I wanted to see whether there was a correlation between the average global temperature rise that's been going on for the past century and average rainfall in Houston. What I'm going to do is get the average rainfall data in Houston through 1970 to 2020 and compare that with the average global temperature as well from 1970 to 2020. Global temperatures have been rising steadily since 1970. There have been numerous reports on how global warming will affect weather patterns in the future, and this is why it was so interesting for me to check up on this. So we're going to construct data which compares the average rainfall in Houston from 1970 to 2020 and compare that with the average global temperature rise from 1970 to 2020. Through this, we'll see if there's a correlation between that data and if there is not. This was my first data set. It is for 1970 to 1979, average yearly Houston rainfall. Average rainfall per year is listed on the left. It's 1970 to 1979. The mean is going to be 50.05. The median is going to be 49.945. We have the lower quartile, which is going to be 45.745. We have the upper quartile, which is going to be 53.7075. We have the standard deviation, which is going to be 10.0769. And then we have the standard variance, which is going to be 101.544933. And then you can see our graph right here, which is, it's pretty steady. There are certain years where, like for instance, 1973, where the average rainfall was 70 inches per year. And then it goes down as 1977, where it's only 34.94. So the way that it went up to 70.16 inches and then it went down to 34.94 also affects our mean, or affects our median, affects our standard deviation, everything. So that's a good eye to keep on that data. Here we have our data for the average yearly Houston rainfall from 1980 to 1989. We have our data on the left, average rainfall per year. We have our mean, which is 44.957. We have our median, which is 46.56. We have our lower quartile, which is going to be 41.1675. We have our upper quartile, which is going to be 51.8325. We have our standard deviation, which is going to be 9.557. And then we have our standard variance, which is going to be 91.34682. Looking at our graph, it's pretty steady from years 1 to 8, which is going to be from years 1980 to 1987, and then it picks up very sharply at the end over there. It actually drops at 1988, and then it picks up from 1989. So it looks like there was a drought in 1988, looking at the data. Here we have our data from 1990 to 1999. The average rainfall per year is listed on the left. We have our mean, which is 48.547. We have our median, which is 48.48. We have our lower quartile, which is going to be 42.895. We have our upper quartile, which is going to be 57.2025. We have our standard deviation, which is going to be 10.5485. We have our standard variance, which is going to be 111.2725. Our graph is pretty steady from years 1 to 9, which is 1990 to 1998, and then it drops sharply in 1999, most likely because there was a drought in that year. Looking at the data, it's pretty clear to see that it was pretty steady, and then it's pretty clear to see where there's droughts or where not a lot of rain happens or anything like that. So here we have our data from 2000 to 2009. This time of period was pretty interesting because we had multiple hurricanes hit our city. We have our average rainfall per year on the left, and then our mean and median and all that good stuff on the right. Looking at our hurricane years is going to be 2001, where we had average rainfall of 71.18. Then we have 2004, where we had average rainfall to 65.06, and then 2007, where we had average rainfall of 65.52. Our graph is pretty steady, but you can see that this time period was actually there was actually a lot more rain than in other time periods of Houston, like compared to 1970, compared to 1980, compared to 1990. This period of time, 2000 to 2009, we had a lot of hurricanes and we had a lot of rain in Houston. So our mean is going to be 55.389. Our median is going to be 55.43. Our lower quartile is going to be 47.16. Our upper quartile is going to be 63.715. Our range is going to be 22.997. That's going to be our maximum value subtracted by our lowest value. Our standard deviation is going to be 10.0012. Our standard variance is going to be 90.022. This time period, which is 2010 to 2020, was also pretty interesting. The reason being we had multiple heavy rain events. It's the beginning of the decade started out pretty tame, and then it got pretty bad as we got into 2015 to 2020. So our mean is going to be 51.52. Our median is going to be 51.93. Our lower quartile is going to be 42.52. Our upper quartile is going to be 58.49. Our range is going to be 55.12. Our standard deviation is going to be 15.412. Our standard variance is going to be 215.947. We had several years of a lot of rain, over 60 inches per year. We had one, which is 2015, which we had 70 inches of rain. We have 2016, which we had 60.96 inches of rain. We had 2017, which is Hurricane Harvey. We had 79.69 inches of rain. And after that, we had over 50 inches of rain in 2018, 2019, and coming up to 2020 as well. So I did a linear regression on this, and I found this. I constructed a scatter plot as well, and I found this data. It shows it's y equals 0.13615x plus 46.58144. That line shows that it may not be much, but average rainfall in Houston is slowly following an increasing trend where it's going. Where 1970 it was rain, but it wasn't as much as let's say in 2020. Where 1970 it was pretty tame. We had one rain event which is over 70 inches. In 2020 to 2010 to 2020, we had three rain events which were over 60 inches. So, but this linear regression basically shows that, however slowly, it is following an increasing trend where it looks like as temperatures rise, we have more rainfall in Houston. These are my confidence interval estimates. These are for 95% confidence intervals. We have 1970 to 1979, 44.3 to 56.8. We have 1980 to 1989, 39 to 50.9. We have 1990 to 1999, 42 to 55.1. We have 2000 to 2009, 49.2 to 61.6. We have 2010 to 2020, which is 42.4 to 60.6. These are all based on 95% confidence. These are going to be my hypothesis. So there's a website called climatecentral.org. It claims that our rising global temperatures will intensify rain events and generally lead to more moisture in the atmosphere, which increases rainfall. Since they're making a general observation, we can use our hypothesis as 50.05, which is going to be the mean average rainfall from 1970 to 1979. And then we'll compare that hypothesis, which is 50.05, to alternate hypothesis, which would be where the hypothesis isn't 50.05. So the reason we're selecting it from 1970 to 1979 because we want to see a trend where the mean goes up where the mean goes up as average global temperatures rise. Moving on, we have our null and alternative hypothesis. Our first null hypothesis is going to be 50.05, and our alternate hypothesis is going to be anywhere where it does not equal 50.05. Our rejection region is going to be z is greater than 1.96, or z is less than negative 1.96. And our after doing the calculations, I found that our test statistic is going to be 0.000853. After looking at this, since z equals 0.00853, it is not in the rejection region, and then we can move forward with our hypothesis that global warming leads to a rise in rainfall. This is my empirical of 1970 to 1979. Our mean was going to be 50.05. Our standard deviation is going to be 10.07. Doing the 95% confidence interval, we expected 95% of values to fall within 43.8 to 56.3, and we expect 99.9% of values to fall within 39.5 to 60.5. Looking at the actual data, we had 3 years where values did not fall in the first standard deviation, and the same with 99.9%, where 3 years also did not fit in. The reason being, some data could not fit in standard deviations and confidence intervals is because there are certain years where in that data where there was a lot of rain in 1970 to 1979. So, for example, 1973 we had a lot of rain, but then as we moved down, we had years where there was drought as well. So that type of discrepancy in data affects the mean, the standard deviation, and it also affects our confidence intervals. This is going to be my empirical data of 1980 to 1989. Our mean was 44.957. Our standard deviation is 99.557. So we expected 95% of values to fall within 39 to 50.09. We expect 99.9% of values to fall within 35 to 54.9. Looking at the actual data, we had 4 years where values did not fit in the 95% confidence interval, and 2 years where values did not fit in the 99.9% confidence interval. The reason being, again, because of there's certain years where there's a lot of rain, and then certain years where there's not a lot of rain, and that really affects our confidence intervals, because it's not exactly as steady as the intervals want them to be. This is our empirical of 1990 to 1999. Our mean was going to be 48.547. Our standard deviation is going to be 10.5485. We expect 95% of values to fall within 42 to 55.1, and we expect 99.9% of values to fall within 38 to 59. Looking at the actual data, we had 4 years where values did not fit in the 95% confidence interval, and 3 years of values did not fit in the 99.9% confidence interval. Again, the reason being is that there's some years where we had a lot of rain, there's some years where you didn't have a lot of rain, and that type of discrepancy affects the confidence interval very much. This is going to be our empirical of 2000 to 2009. Our mean was 55.389. Our standard deviation is 10.00122. We expect 95% of values to fall within 49.2 to 61.6. We expect 99.9% of values to fall within 45 to 65.8. So we had 6 years where values did not fit in the 95% confidence interval, and 2 years where values did not fit in the 99.9% confidence interval. The reason we had so many years is because this time period was where we had 3 hurricanes within this decade. So it looks like and the other years were not as rain intense as the hurricane years. So the reason because of this discrepancy is, again, because there's some years where we have a lot of rain, some years where we do not have a lot of rain. And this is going to be our last empirical. It's going to be of 2010 to 2020. Our mean is going to be 51.52. Our standard deviation is going to be 15.412. We expect 95% of values to fall within 42 to 61.1. And we expect 99.9% of values to fall within 35.5 to 67.5. We had 4 years where values did not fit in the 99% confidence interval, and 3 years where values did not fit in the 99.9% confidence interval. This data is from the average rainfall per year from 1970 to 2020. This data is very interesting because it shows the amount of rainfall events that have happened over 65 inches from 1970 to 2020. From 1970 to 2000, we only had one rainfall event, which was over 65 inches. That was in 1973. From 2000 to 2020, we had 5 rainfall events that occurred that had rain over 65 inches. The reason this is so interesting is because as we see global temperatures rise, we also see the amount of rainfall events that are over 65 inches in Houston also go up as well. This shows the average global temperature from 1880 to 2004. The most interesting part of this graph is what I actually highlighted. This shows the cutoff at 1970 to 2004, but as you can see, as the temperature rises, we also get more rain events, as you can see from the previous slide as well. So I thought this data set was pretty interesting. In conclusion, a lot of our data for rainfall did not fall within confidence intervals because there are certain years where there was not as much rainfall as other previous years. This contrary with the fact that there were years with quite a lot of rainfall skewed the standard deviation data. Although it is hard to see a correlation between rising global temperatures due to global warming and the yearly rainfall average in Houston, one data point is clear: the fact that rising temperatures have a clear correlation on the number of high rain events in Houston. This means that as temperatures rise, as global temperatures rise, there are going to be more rainfall events that happen over 65 inches in Houston.